Okay, so very good afternoon, my dear students. We have started about, we have already started about the discussions on different modules. Okay, different modules of electrical utilizations, the E3102. Okay, so in my last class, so today I am going to discuss about I'm going to discuss about the first module. Okay, so we are going to be started about the first module, that is our electrical tractions. Okay, so in my last class I discussing about the different ideas. Okay, so different ideas of our utilizations, means so why the subject are important. Okay, and especially from electrical engineers point of view, so why we are going to discuss about the subjects, what are the most important features. Okay, so we are starting with the traction system. Okay, so it's not like that mechanical tractions, it's about your electrical tractions. Okay, so mechanical tractions also been possible. Okay, but our main concern or our main focus is electrical traction, so that's why we are we are most bother about this electrical tractions. Basically tractions means, you know, that different means applications of traction, especially we are using for the locomotive system. Okay, so here we can see some diagrams of that different locomotives. Okay, so I hope my slide is visible from your end. Okay, so here you can see that driving system. Okay, so there is no pantograph. Okay, in this diagram you can understand there is no pantograph. The why the pantographs are not there, that means the driving energy is coming from that fossil fuel energy. Okay, fossil fuel energy means diesel energy. Okay, so here you can see that diesel energy is there, and I hope you are aware about that combustion engine. Okay, internal combustion engines, I say engines. Okay, so how that energy, chemical energy, converted to the stroke. Okay, so two stroke engine, four stroke engine means 2T, 4T, 6T. Okay, so different strokes are there. Okay, based on that strokes, if the number of strokes are improved, so efficiency of that engine also been improved. Okay, so for if you're going to compare then two stroke to four stroke, so you can understand there is a combustions, the fuel combustions is not done full phased way, means nor on when partial fuels are, means it is, you can understand that the fuels is not properly oxidized, means semi oxidized. Okay, so if you want for properly oxidizations or properly consumptions of the fuels, okay, so definitely you have to increase the stroke size. You have to increase the number of stroke. Okay, so you know that in our in normal power plant, okay, we are using the coals. Okay, we are directly not using the coal, we are using pulverized coal. Okay, pulverized coal means you are pulverizing them through the grinding system, so the coals are just like a powder. Okay, coal powder, and there is a huge you know that FD fans are there. Okay, so you are giving the blower. Okay, when installing the blower to the pulverizer. Okay, so that can the motivations of that blower to make them coal. Okay, that will be in mixing with the air. Okay, the pulverized coal will be mixing with the air. Now you are going to burn that coal, so 100% consumptions are there. Okay, so like that one, the when you are converting the stroke, so mechanical energy, so stroke engines directly related to the mechanical one. Okay, electrical energy, then you are using that electrical machines. Okay, suppose directly you can say like the electrical motor for driving that pinion gear bearing for that driving your wheels. Okay, our main motivation is what, for the tractions. So we have to overcome that friction. Okay, friction means static frictions. Okay, so our railway wheels are there, railway tracks are there, we are moving our loads means whatever you have the engine. Okay, you are having that engine, and that load means lot of bogies are connected with your engine. Okay, so that are responsible for driving your bogies. Okay, it may be goods carrier, it may be passenger train, it may be mail train, whatever. Based on their efficacy, the speed of that engines are varying. Okay, so here you can see different generations of the engine. Okay, that the very old generation, you know, that steam engines from mid 90s. Okay, so you know that steam engine mid 90s, how it will be look like that. So all are in stroke engine. So where what happen in steam engine? So you are getting that means force. Okay, so for the movement of your wheels. Okay, that is coming from the steam. Okay, so here you can see the different types of locomotives. Okay, so it is electric locomotive. How do you understand electric? So pantographs are there. Okay, pantographs are there. Okay, normally one engine you can see one pinto is already raised up. Okay, operated. Another one is there. Okay, that is not. This is backup pinto. Okay, so one engine having two terminal, two sided. Okay, it may be work front side as well as back side. Two one coach contain the two engines like that. Okay, so any of the direction you can move them. Okay, so what are the most important features? The distraction system, it's the classifications. Okay, how do you classify them? Okay, classifications, the nomenclatures. Okay, power system of the electric traction, very important thing. Okay, so how do the make the power system or power supply? Power supply is one point. Okay, you can select the power system of your electric tractions. Okay, that is very important. Means how do you get the power, then how, which conversions are there for feeding your system. Okay, so based on that, right now most of the cases, you know that in India right now all the things are designed here. Okay, initial days when the Rajdhani Express was there. Okay, so that was our money outsourcing from Switzerland. Okay, so initial days, very initial days. Okay, so then what happened in Chittaranjan? Okay, they are designing the, now they are designing the engines of the Rajdhani Express. Okay, so who is that company? So Wales are providing the machines and engines are Wales. Okay, and engines are after getting the machineries, all the things are assembled in the Chittaranjan. Okay, now different rakes are there. Okay, modified rakes are there. Now generations has changed. Okay, so tractions are also changed, but basic fundamental things are not still changed. It is like that. So it may be the DC as well as AC. Okay, so DC system for what? Normally in initial days we're using DC series motor for the traction purpose. Okay, not very initial days. Till now, some of the cases you can see some DC series motors are there, like electric multiple unit EMU. Okay, so that city rides, some of the places are there. Okay, that the electric trains are very available, so it is using just like a city ride, like Mumbai, like Kolkata. Okay, so they are using that electric train as a city ride. Okay, so and not now, from that in the time of British government, that time also it was there. So you know, there is city ride means you are suppose that is your then Chennai, you can also see Chennai, Bengal, Chennai, Kolkata, then Mumbai as well as Delhi. Okay, Delhi, Delhi, some of the trains are there, but not so much frequent. But in case of Mumbai, Chennai, and Kolkata, that is very frequent. Okay, I saw them, so that's why I can tell you. So EMU means electric multiples units are there. Okay, so in that case we're using that DC motor. Okay, DC series motors are there. Okay, but now that motor has changed to the inductions. Okay, and their total, how the electricities are coming from that pantograph means overhead line to your motor. Okay, so individual path, everything I'll be discussed one by one. Okay, then traction motors. Okay, which motors are important? So that I'm telling. So DC series motors are there, as well as now inductions motor also using. Okay, so why there is some basic difference between DC series motor, DC motor as well as the AC motor. Okay, the performance. Okay, overall performance in the presence of different for low with low maintenance. Okay, the overall performance with low maintenance. You can see that AC motor means induction motor gives a better means better efficient, means better cost efficiency in point of view. Your means you have to maintenance work less, so costing regarding the maintenance work is quite less. Okay, that's why AC night right now that all kinds of things are converted to the AC. Okay, control of the traction motor, which controls are you are using. Then most important thing, braking. Okay, so which type of braking you are using for your traction motor. Okay. Then tractions means what you are using the locomotive on the rails, driving force, steam or electric drive. Maybe you know that steam means whatever the how do you get the steam. So definitely that water should be coming from boiling of that water. Okay, if you using diesel, the same thing also happen. Okay, so you are giving the fuel. Okay, diesel is like a fuel, then combustions of that fuel. Okay, whatever the conversions, chemical energy to mechanical energy. Okay, mechanical energy, or you can say like that mechanical energy to electrical energy. Okay, whatever electric motors are there, so chemical energy if you use there, so based on the chemical energy combustion, the piston, if you see that stroke engine, so if you want to see the stroke engine, it's like a tube and one piston is there. Okay, the movement of the pistons. Okay, how much full movement is there, it based on that it may be 2 stroke, it may be 4 stroke, etc. Okay, so like that. Okay, so in diesel what happened, you are using the combustions. Okay, so that the combustions is there, based on that combustions that piston is moving. Okay, piston is moving, and based on the piston movement you say like that wheels. Okay, that piston movement directly connected with your wheels of the locomotives. Okay, so wheels also moving. Okay, so in case of electrical energy, what is the benefit? Benefit is that such type of complicated things are not there. Number one, the pollutions. Okay, diesel engine, you are using that combustions means there is oxidations of your fuels. Okay, partial oxidations means there is a high chances for development of carbon monoxide. Okay, so full combustions means not less value, less quantity of carbon monoxide, but carbon dioxide will be there. Okay, but these kinds of things are there, a lot of things are there for the, those are responsible for the air pollution. So you have to avoid the fossil fuel, means you have to switch the thing for the AC traction. That's the basic motivation for converting into conventional enter that fossil fuel based transportation to electrical transportations. Okay, and classifications of the system. Okay, non-electric and electric. So non-electric means based on that fossil fuel, diesel, whatever I am telling. Then electric means receive from electricity externally, self-continuity locomotives. Okay, electric engine means sometimes diesel also using. Okay, so diesel you are using, you know that different occasions we are using diesel generator for our captive generations in our home. Okay, suppose any occasions are there. Okay, so suppose we are using the silent generator right now. Okay, few years back silent generators are very much common for last 5 6 years. Okay, like last 10 years approximately, but before that what we are using, before 10 years we are using, we're booking some alternator. Okay, so where we are giving the kerosene, mixing of kerosene diesel compositions, and we are driving then that there is also combustions. Okay, the combustions is are there, means piston is there, based on that combustions that is responsible. Combustion means chemical energy to convert to the mechanical energy, and that mechanical energy is given as an input to the generator, AC generator, alternator. So that mechanical energy is given to the prime movers of that alternator. So that mechanical energy is responsible for movement of your prime mover, and prime mover is movement of the prime mover inside of your magnetic field. So cut off flux, and that is responsible for generation of the electricity, and you can utilize that electricity. Same thing happened for your non-electric locomotives also. Oh, sorry, electric locomotive, but self-continuated locomotive, same thing also happened. You are giving the fuels. Okay, you are giving the fossil fuel for that combustion purpose, and you are getting the mechanical energy. From the chemical energy to mechanical energy conversion is there. That mechanical energy you are using for movement of the sap movement. Okay, and that sap movement is responsible for as in prime mover. Okay, so moving of the prime mover of your alternator. Okay, so you know that when the Rajdhani Express is there, not like only Rajdhani Express, AC, full AC rakes are there. You can see uh, just bottom coach, the guard coach, just before the guard bottom coach, and before the guard coach, you can see one coach is there, that is called generator coach. Okay, you can see Shatabdi Express, Rajdhani Express. Okay, most of the prime train, so you can see like that generator coach. Okay, that's the responsible. So generations will be there, it having that inherent bus system. Okay, from that bus system they are providing the supply, and that motor also running in inherent bus system. Okay, so it's based on that self generated. Okay, receive electricity from external means those electric uh, that Rajdhani Express and Shatabdi Express, these are very prime train. Okay, they are having two content money, they are having two options. It can also take power from directly from pantograph. Okay, for only based on your electricity, external electricity, so pantographs are required. Okay, so you can apply upright your pantograph, or it can touch to your wire, means contact wire just above of your chain, just above of your electric locomotive. Okay, so there are two wires, one is called contact wire, another one is called the catenary. Contact wire provide you the mechanical state, catenary is providing you the basically supply. Okay, so pento is touching with your catenary. Okay, so pantographs are collecting the current from there, and it can give directly supply to your electrical machine. Means what type of machine? Electrical motor. Okay, and that motor is responsible for movement of your wheel. Okay, if that sub vento is not there, so that diesel is there. Diesel is responsible from prime mover movement, and that prime mover is responsible for generation of the electricity, and that electricity is fed to the motor of your locomotive. Okay, motor of your locomotive, and that power is used for the driving of your wheel. Okay, so driving of motor of the locomotive, now it is converting the mechanical energy, electrical energy to mechanical energy, and that mechanical energy means movement or tractive effort of your locomotive. Okay, that's the basic operations. That's the basic classifications. Okay, classifications of the traction system. I hope all of you are able to understand. If any doubts are there, you can ask me. All of you are understood whatever I telling? Is there any doubt?
No, sir.
Okay. So now what are the nomenclatures of your of Indian Railways? Okay, so that's nomenclature is very important. So nomenclatures means we are using which type of four parts. Okay, so like the WDP2. We are taking some example. Four parts are there. I'm taking some example. The locomotive is like the WDP2. Okay, what do you mean by W? W is like that gauge type. Okay, so there is a BG. BG means broad gauge. Okay, BG means broad gauge. That stands for W. So W means that locomotive is there. It is broad gauge type of locomotives. Okay. Instead of W, if you using YDP2, that if you using YDP2, so Y means medium gauge. Okay, and Z is your narrow gauge. Okay, now broad gauge is everywhere. Okay, so why you know that broad gauge is everywhere. Okay, but some of the places was there. Okay, where the medium gauge and narrow gauge are there. Some of the places that I know, some of the routes. Okay, where it was there. Like you, if you go to Shimla. Okay, so if you're coming from Shimla to Kalka. Okay, I hope you know our about the name Shimla to Kalka. There is a like that toy train. Okay, so toy trains are there in not like only the Himalayan railways. Okay, that the Shimla to Kalka. Then those are from those one to visit from Darjeeling, from New Jalpaiguri Junction. Okay, so that NGP to Darjeeling Ghum. Okay, so that range. Okay, these all are the examples of a narrow gauge. So what is the meaning of that narrow gauge? So broad gauge, meter gauge, and narrow gauge. Okay, M for meter gauge means the span. Okay, the span in means two of the way railway tracks. So railway track having the track in the distance between the track. Okay, that is based on your gauge, that is defined by the gauge. So it having some standard distance. Okay, so narrow gauge means now narrow gauge and meter gauge both are meter gauge means the span is the difference of the span is meter, 1 meter. Okay, now all are obsoleted. Okay, why they are obsoleted? Basically for that special cases, if you have the special track. Okay, so you need to design some special coaches. Okay, for the special track. Now all the routes are not so much popular. Some of the popular route I am telling you. Okay, so another track maybe there that I don't know. Some other places the toy train service also be there. Okay, so these all are the special case. Okay, so for this only special case, tourism purpose, you need to design that special type of coaches. But in India, some of the track are still there. Okay, now very old track was there in Mayapur. Okay, in Mayapur Navadip. Okay, there is a very old track that was narrow gauge. Okay, it was 135 years old. The track was there. Another track was there that was from basically I saw them. That's why I'm telling. So another place is there in West Bengal. So that was also more than 150 years old. Okay, so both the track last 10 years back they have just stopped. They have just stopped. To explore that means to run train. Okay, run narrow gauge train in this route. Why? The scarcity, there are different problem. Number one problem is there, that is your good carrying capacity of your system. Means whatever locomotives you are using, okay, they are in narrow gauge means their rating of the motor is quite different. Okay, if the motor rating is different, that means they are in lesser in volume. Okay, and the rating also been less compared to the conventional railway system. Okay, then problem is that the carrying capacity means load carrying capacity also been less. Okay, so it is not profitable. Okay, it is not profitable. That's why they are changed to that narrow gauge to narrow gauge or meter gauge to the normal broad gauge. Okay, normal broad gauge condition. So it may be the normal local EMU. It can travel in this route and they can carry the passenger as well as the good. Okay, that's why it's very important to identify what type of gauge is there. So it is, that's why it is writing W or Y, W slash Y slash Z, whatever. Then A or D. Okay, here you can see D is there. Okay, D stands for diesel, A stands for AC. Okay, sorry, D stands for diesel electric, A stands for AC tractions. Okay, so what type of mode of tractions? Okay, that A stands for AC traction, D stands for diesel electric traction, non DC tractions. Okay, then you know, like, then it is P. Okay, P means what? P stands for passenger. Okay, so passenger, G for goods, M for mixed passenger and goods, S for shunting. Okay, shunting means free running. Uplifting means it's that configurations is different. Okay, so whatever configurations are there, then two model number. So number of machines. Okay, how much machines are there? Okay, so two means in one coach there are two machines. Four means one coach, four machines are there. Okay, six means this side means left side three machines, right side another three machines, like that. Okay, so traction machines, that stands for that number. Okay, so it is what was there? So it is diesel electric passenger train running on broad gauge. Okay, diesel electric passenger train, P for passenger. Okay, running on the broad gauge. So by that way, we are giving the names. Okay, that names is written just beside of your locomotive. Okay, if you travel any of the place, you can see that locomotive, that engine side, it is mentioned. Okay, some numbers are there. Okay, so based on the numbers, you can defines that the characteristics of the locomotive. Okay, That's why it is known that nomenclature in Indian Railways. Okay. So here the gauge distances are there, broad gauge or standard gauge, that difference is there. It is 1.676 meter. Okay, gauge width. Okay, types of gauge used in our railway system. Then meter gauge, so span is what? 1 meter. Okay, narrow gauge, this is 0.762 meter. Okay, and last one is that light gauge LG, that is 0.610. Okay, so based on that gauge you are fixing, you can define your system. Okay, types of the railway service, most important thing at the time of exam, one question will become from here, the type of the railway system and their calculations of that curve, how the speed is getting, means what is the total displacement distance traveled by your locomotive, which characteristics, one question will be there. Question as well as numerical problem. Okay, so what are the types of the railway service? That is mainline service. Mainline service means you are traveling from one state to another. Okay, so distance is more than 150 kilometer. Okay, so that is your mainline service. Okay, then city service or urban service, so you are going to travel from intercity, means one city to another city or one urban to another urban. Okay, that is the urban service. And city ride service, that is called the suburban service. Suburban service means inside of the city maybe multiple stations are there. Okay, suppose those are familiar with that EMU, electric multiple units, they can know that the distance between two consecutive stations, okay, distance between two consecutive stations are in between that 5 kilometers, 5 to 10 kilometers in between. Okay, maybe 7-8 kilometer. Okay, so for two stations, okay, consecutive distance between two stations means two stoppage of the locomotives. Okay, EMU, especially we are using the EMU. Okay, so that happens in your suburban service. Okay, the system for the track electric. Hello.
Sir, what
Hello.
will be written for
Tell
LG?
me. Your voice is not coming. Can you please write in the chat box?
Sir, what symbol
Hello.
will be written for LG?
Tell me. Okay, so if you have any query, you can write in the chat box. Okay. So system of the electrifications. Okay, so what type of
Sir,
electrification system? Hello.
I have written in the chat box.
Okay, so it is written that LG means you have to write that LG. Okay, that LG means you have to write LG. Like other cases, what you have written? You have written W, Y, Z. Okay, X, Y, W, X, Y, Z, like that. So LG you can write. Okay. Now, what are the basic important thing that your electrifications of that our tractions? Okay, so electrifications means what type of electricity we are using. So in railway system, you can see most important thing that the specifications. Okay, the specifications and the rating. Okay, the specifications and rating are quite different. Okay, normally in our distribution section or whatever we are using 33 kV. Okay, distribution section we are using 33 kV or 6 or 11 kV. Okay, but in railways you can see it is using 25 kV AC. Why? The basic question is that why? Okay, so 33 kV is the standard. Why 25 kV? Okay, so then we are using the 25 kV to now stepping down as per our rating. Okay, basically 25 kV means so nobody can steal that power. Okay, so basically that only uncommon specifications are normally designed only for the railway system, and whatever companies are supplying the materials for to the rail, so that is quite uncommon. Okay, and that quite uncommon, so nobody can steal that amount of power. So if 33 kV means anybody can take it, so it's very common. Okay, but 25 kV is quite you know that it's quite uncommon, and most of the railway tracks you can see the power supply. Okay, power supply, power system, and no, it's situated like unprotected conditions. Okay, suppose anybody, if it's free running conditions, so anybody can take it. So that's why make it some odd specifications, so nobody can take directly. So if you see the wire of the tractions or wire of the railway system, that also quite different. Okay, it's not directly look like your common all aluminum conductors or aluminum conductors and steel reinforced ACSR conductor. Still it is ACSR conductor, but it is look like a different. Okay, it's different structure, everything is different. Okay, so that's why it's specially designed for your railway system to not to steal, not to stolen by the anybody. Okay, so no, if anybody take this one, so they cannot be used, okay, for this their purpose. That's the main reason. Okay, so what type of supplies are there? So normally initial days it was DC. Okay, now the system is used by the AC. Okay, so you know that Delhi Metro. Okay, Delhi Metro, Calcutta Metro. Okay, different metros are there, and their specifications also different. Delhi Metro, you know that it is you know that contact wire. Okay, the current carrying portions, that is your upper side of that metro. Okay, just above of your metro. But if you go to the Calcutta metro, okay, you can see that power supply is taken by the locomotive. Okay, this is not your just above of your head. Okay, this is beside of your track, beside of your railway track. So there is some extension from your bogie that can directly collect that power from the track. Okay, so based on that, but that energy is not the AC, this is DC. Okay, and that AC metro and Delhi metro that I'm telling, their upper side, that railway, that wires are there, that is in AC. Okay, so based on your system specifications, based on your availability of the machines, and that especially the system specifications, okay, you have to give that electrification, whatever DC or AC. Okay, decide that you have to decide. Then single phase low frequency AC system, single phase high frequency AC system. So normally what frequency level we are using for the supply, it is 50 hertz. Okay, but some of the cases you know that in locomotive also having some emergency power supply. Okay, suppose there is a battery bank. Okay, charging of the charger, bidirectional chargers of the battery banks. Okay, so that charging the charger switches are using, what type of switches you are using, their switching frequency is different. Okay, so you are very high also, different and high, and that's also conversions from the single phase to means AC to DC or DC to AC, whatever conversions are required. So based on that, different types of frequency you are using. Normally you are using that 50 hertz system in our Indian railway. Okay, then three phase AC system. Okay, if you use the control system, okay, suppose if you are using three phase configurations, that also be there. So three phase AC also been possible. So in that case, we have to design some specific calculations. Okay, so everything was there. Single phase, three phase. Right now, single phase is most common and most popular. Okay. Then composite system, single phase to three phase conversions or single phase to direct current conversion. So single phase to three phase conversions, normally what we are doing, so we are using inverter, okay, but in that locomotive initial days there was using some Arno converter, okay. So Arno converter is in machines, okay, that machines is responsible for this conversions. Then power electronics are gradually improve in these domains, and now they are very familiar. So you are not you can, that entire system will be replaced by the solid state device, okay. So if you are using solid state device, so some of the case extent you can reduce the losses, okay. Some of the extent you can also reduce the losses and implement implement that thing to your system, okay. Then single phase to three phase system, single phase to DC system, okay. So that whatever system, suppose your machines in DC, so you are getting the AC power, okay, from your overhead contact wire, okay. From there you are using the pantograph carry that current and it is coming to the transformer through a isolator and circuit breaker, through a isolator and the circuit breaker, okay. So which type of circuit breaker you are using, okay. Initial days you are using air blast circuit breaker, okay. And now they are using that, what type of circuit breaker? Vacuum circuit breaker. Air blast circuit breaker for initial days. Now they are using vacuum type of circuit breaker. Okay. And that SFC circuit breaker is not so much common. Okay. SFC circuit breaker we are using for where? We are using for substations. Okay. Transmission substations, especially. Okay. But in this railway system, okay, you are not using that SFC. That's that vacuum circuit breaker and that air blast circuit breaker. Both are the more than sufficient to breaking the circuits. Okay, these are the very basic concept for the electrifications. Okay, now here you can see the power supply. Okay, the power supply of the electric tractions. Okay, what are the important thing? First one is that contactor of the railway, contactor railway system, overhead system. Okay, so this is contact strip. Okay, so contact strip is there. From these two strip, it is touching with your overhead contactor. Okay, so overhead conductor having two wire. Okay, one is called catenary, another one is called contactor. What is the purpose of the catenary? That can provide you that supply, continuous supply to your contact wire. Contact wire cross section is look like 8. Okay, if you make the cross sections, okay, if you make the cross section of the contact wire, you can see it's look like a 8 type of shape. Okay. So what is the purpose? So that's holding the contact wire from that the just beside of your track there is some pillar. Okay, so there is some support to holding the contact wire of your track. So that's why it is look like H shape. Okay, and just before through the dropper your contact wire is connected to your contact wire is connected through the catenary wire. Okay, that catenary wire, that contact wire is totally designed by that solid, okay, solid copper and cadmium. Okay, cadmium provide you the mechanical strength, copper provide you that good electrical strength. So without having any many good electrical strengths, okay, as well as some current carrying capability good, okay. And that contact wire, it's a aluminum conductor steel reinforced ACSR, okay. So that provide you that mechanical strength, and continuous supply provide you the continuous supply to the contact wire. Okay, these two are the very important. Okay, so here we can see the basic important points of that pantograph. Contact strips. Okay, so from here you can see the two contact strips are there. Then horns are there. Okay, horns by these two horns you are connecting. Okay, something, and that pantograph arm. Okay, then you can see the pantograph arm. Okay, so from that pantograph, so from that way, so your pantograph can be moved up and down. Okay, your pantograph can be moved from up and down based on your based on your applications. Okay, so sorry, based on your application. So based on your requirement. Okay, so when you don't want to uplift the pentograph, you can means switch off condition, so you can make it down. Okay, so pentograph and its different bar. So you can see the overhead line, how it will be look like that. Okay, overhead line category. Okay, so there are some boosting transformer. Okay, so this point I will discuss in my next slide, return part. So that overhead category, how it will work, that I can see dropper. Here you can see the catenary wire. Okay, this is your ACSR catenary. Just below this is your contact wire, and droppers are connected like that. Okay, so these are the holding your wires. Okay, so I'll discuss in my why it is called return path. Okay, that portions I'll discuss in my next class. Okay.